Hello. So we have seen the free body diagrams, and basically we will use the equations of equilibrium to find out what are the magnitudes and the directions of those reactions, of those supports. Uh, Remember that at equilibrium, the net force and moment acting on a body are always zero. So the sum of the forces in x equals zero, sum of the forces in y equals zero, and sum of the moments about point O equals zero. If you have 3D, then you have moment in x, y, z, and then you have sum of the forces in x, y, and z. Uh, so these three equations are the three equations most commonly used uh, for equilibrium. So remember, this is in terms of a vector, sum of the forces equals zero, and sum of the moments equals zero. If it's 2D, then you have sum of the forces in x and sum of the forces in y, and then sum of the moment at any point equals zero. If the system is at equilibrium, any part of the system is also at equilibrium. So it doesn't matter if you take the whole system or part of a system. So remember, establish a suitable xy coordinate system is the first step. Xy, draw a free body diagram, apply the three equations of equilibrium to solve for the unknowns. If there are more unknowns than the number of independent equations, then we have a statically indeterminate situation. We cannot solve this problem using statics. So we have three equations, so we can have a maximum of three unknowns for statically determinate structures. But if it's more unknowns than equations, then you have a different situation that cannot be just solved with statics. The order in which you apply the equations may affect the simplicity of the solution. Now we have to go back at how to solve equations. In Blackboard, you have Khan Academy videos that shows you how to solve a system of equations. If the answer for an unknown comes out as negative, then the sense or direction of the unknown force is opposite to what you assumed when started the problem. So let's just show this brief example. You have the beam is supported by a roller at A and by a pin at B. So this is very important that it describes what. So you need to show what are the reactions at point A and at point B. And of course, you have to establish an X, Y coordinate system and then draw a complete free body diagram of the system and apply the equations of equilibrium. What I like to do is basically, first of all, to have the free body diagram. So this is the roller. Remember, you look at it independently. This prevents motion in this direction, but not in this direction. So you have only this reaction. And then here you have a pin. So it prevents motion in this direction. So when I look at this specific point in the context, this pin does not prevent any rotation, so I don't have a moment. Okay? So then the other thing that's done is, in this case, we have a distributed load. So we reduce it to a single force and find the distance. Now, the first thing is, if I write the moment about this point, I don't have to worry about the magnitude of B and X because the moment about that point is not affected by those forces. So if I do some of the moments about this point, then I can determine the magnitude of A directly. Now, if I had the sum of the forces in X and sum of the forces in Y, I have too many unknowns. So this is what it mentions about the simplicity of the equations. So you have to take a moment or a minute, so you don't get confused, to look at the system and see how can I get one solution, one of the unknowns. And the sum of the moments is always a beautiful thing to start with if you have three unknowns, because that eliminates two unknowns. Once you have that, then you can do some of the forces in X or Y. Okay, so in this case, we have some of the moments about point B. So this point B is affected by this 12 kilonewton force and by this normal force. Okay, So this is the angle here of 30 degrees. So it's kind of complementary angles. Um, and so you have the cosine would be in the y direction, but also the x direction affects the moment because at this point you have the force going, so you have this distance and also you have this distance affecting the moment. Okay, so if you have to take a minute to look at these equations, these slides are posted on Blackboard. Take a look at them and study them before you have to work on the problems. So what happens is that then by doing some of the moments about this point, you get the solution for NA directly. Then you write some of the forces in X and some of the forces in Y and solve for Bx and By. So I just wanted to talk about the generic procedure, and now we'll work on some problems.